Hello students. So in the last videos I have discussed about interference of light. Okay. Now let me discuss about diffraction of light. Now diffraction means what? Diffraction means bending of light at the sharp corners of an obstacle. Okay. And entering into the region of geometrical shadow. Okay. So let me just take the example. Suppose there is a hole. Okay. So if you allow light to pass through this hole, and if we assume the light travels in straight line, then what happens? If this is a screen, then you will find that if light travels in straight line, then there will be light only in this region. Only in this region you will get light. Okay, you will get light here only. Because if you assume light travels in straight line, then there will be light only in these regions. Here only you will get light. But practically you will find that somewhere, these regions, these are the shadow region, because these are the shadow region. These are shadow region. Because light can pass through this hole only, so there should not be any light. If we assume light travels in straight line, but practically we will get light at this region also. Here also you will get light. In these regions here, you will get light. In this region, you will get light. Okay? That means light entering to the what? Shadow region. Light entering to what? Shadow region. So, why light entering this region? Because of bending. Here, light bends. So, this bending of light is called what? Diffraction of light. So, you can say that light bends at the sharp corners of an obstacle. So, here, when light strike this end, so it bend from these sharp corners. It bend from these sharp corners. Okay, it bend from these sharp corners. So this bending of light is called what? Diffraction. So diffraction is what? The bending of light round the sharp corners of the obstacle and enters into the shadow region. That is called what? Diffraction of light. So here I will explain single slit diffraction. Okay? Diffraction at a single slit. Diffraction at a single slit. Suppose here you consider this is suppose a slit. This is suppose a slit. Here you consider this is a slit. Okay. Suppose there are parallel rays incident in plane wavefront. These are plane wavefront. This is incident here. You consider lens, the convex lens, and this suppose screen. So this is slit, and this is screen. Suppose distance between slit and screen, that is D. D is distance between slit and screen, and this is small d, distance, that is separation, that is the slit width. You can say slit width, it is D. Now here, the light that moves in straight, this center, okay, this is the center of the slit. This point, suppose O. So light that travels in straight, that meet at the point O. Meet at the point O. And you consider diffracted beam. This is diffracted one. Suppose it diffract at angle theta. Okay, bend at angle theta. From there also you take a diffracted beam that bends suppose angle theta. So they suppose meet at this point. They meet at this point. Okay, suppose point P. So the straight one that meet at the center and the diffracted one meet at point P. So this angle also what? Theta. This is suppose YN. Now at this point, this is the central maximum. So this point O is central maximum. This is central maximum. Why it is central maximum? Because you see the waves that travels from this end and from this end, they exactly travel equal path. You see this path and this path exactly equal. That means path difference between two waves meeting at this point is 0. So if path difference is 0, if path difference equal to 0, that means what? Phase difference also 0. Okay? Phase difference is 0. Now phase difference 0 means what? They meet in same phase. So when two waves meet in same phase, that means what? It gives you what? Bright. It gives bright. That's why the center of the screen that always be what? Of bright. Of bright. And that's why it is called what? Central maximum. Why it is central maximum? Because the waves travel, that the waves which is parallel to the central line that meet at point O in equal phase. Since they are in equal phase, so that's why it gives you what? Bright. Now this point P, it may be bright or dark depending on the path difference. Because here you see this path and this path are not equal. So there exists a path difference. How can you find it? You draw a perpendicular there. Okay, you draw a perpendicular there. So this path and this path have a difference, that is this much. So this is suppose path difference x. So this is suppose A, B, N. Now in order to find whether this point is bright or dark, you have to find the path difference. So let me find the condition under which this point will be bright or dark. Okay, this angle also theta. So what do you do? First you find the path difference. So here, to find the path difference, what do you do? Use this triangle. You use the triangle ABN. In triangle ABN, if you take sin theta, it will be what? Perpendicular by hypotenuse. So BN by AB. So BN is x, AB is what? D. So x is equal to what? D sin theta. So this is the path difference. Now from here, we will find the condition whether this point will be bright or dark. So position of nth secondary minimum, that is dark. So in case of diffraction, dark fringes are called secondary minima and bright fringes are called secondary maxima. Now here for nth secondary minima, just let x is equal to lambda. I am considering the path difference equal to lambda. Now if I consider path difference equal to lambda, then what happens? Suppose here a wave incident, that is lambda, from here to here there is lambda. Okay, it is lambda. You know, complete wavelength. That is lambda. Now this suppose incident here. When it incident, you see two waves from these two parts meet at the point P. That means you divide it into two parts. So this part is crest, this part is trough. So when you see at the two part of the slit, it divide into two parts. So here suppose from this part suppose the crest moves and from this part suppose the trough moves. So when they meet at this point P, they will in opposite phase. One crest, one trough, that gives you what? That gives you dark. So if we consider path difference is x, that is lambda, then this can be assumed to divide into two halves. From the two halves, when they meet at point P, they meet in opposite phase and that gives you what? Dark. So if x equal to lambda and theta equal to theta 1, then from equation 1, what you can write? It is your lambda is equal to d sin theta 1. So sin theta 1, it will be lambda by d. So this is the position of first dark or first secondary minima. Okay, minima. Similarly, if we take x is equal to 2 lambda and theta is equal to theta 2. Now you take x equal to 2 lambda. 2 lambda means what? Here you see, if you take x equal to 2 lambda, you see 2 lambda. That means here. So here to here it is lambda, then here to here again lambda. This is 2 lambda. So in this case, now slit is divided into 4 equal parts. So 1, 2, 3, 4. So if we divide into 4 equal parts, then from this part and this part, from here suppose this crest moves, and from here suppose trough, so they meet in opposite phase, cancel out. Then from third one this moves, and fourth one this moves, they are also in opposite phase, cancel out. So that also produce what? Dark. So from equation 1, what you can write? It is 2 lambda equal to what? D sin theta 2. So sin theta 2 will be what? 2 lambda by d. So this is what? Secondary maxima. Okay. Minima. So this way, if we take x equal to lambda, it is first minima, 2 lambda, it is second minima. Like for nth minima, you can write sin theta n is equal to n lambda by d. So this is for nth minima, sin theta n will be what? That is n lambda by d. This is suppose equation 2. Again, in triangle, this one COP. In triangle COP, you can write tan theta n. For nth you can take tan theta perpendicular by base. So you can write it is PO by CO. Now PO is what? Yn. CO is what? D. So from here you can write, okay, so tan theta is equal to what? So tan theta is equal to what? It is Yn by D. Equation 3. Now if theta n is very small, in that case you can always write tan theta n is equal to what? Sin theta n. Or that means Yn by D is equal to n lambda by D. So from here you can find Yn, position, that is n lambda d by d. So this you have to remember, okay. So this is the position of what? That is nth secondary minima, that is n lambda d by d. So position of it is nth secondary minima. So here n is equal to 1, 2, 3 like that. So this way you can find out position of nth secondary minima. So it is very simple. So here we have seen that if x part difference is lambda, then it's cancel out 2 lambda, then also cancel out 3 lambda, then also cancel out, because equal number of crest and trough. Now let me find out position of nth secondary maxima. Position of nth secondary maxima. Now for maxima we use, let x is equal to 3 lambda by 2 and theta equal to theta 1 suppose. Now you see lambda, this is what? 2 lambda. In between lambda and 2 lambda it is what? It is 3 by 2 lambda. Now here I am considering suppose x equal to 3 lambda by 2. Now 3 lambda by 2 means what? You see, 3 lambda by 2 means what? Here suppose it is 3 lambda by 2. 3 lambda by 2 means what? This one. From here lambda by 2, lambda by 2, lambda by 2, 3 lambda by 2. So in this case the slit is assumed to be divided into 3 equal parts. It divided 3 equal parts. This is 1, this is 1, this is 1. 3 equal parts. Now from the first part, suppose this crest moves. From the second part, this trough will move. Okay? So when they meet in opposite phase, so cancel out. But from the third part, this will move, so which remain unaffected. So this gives what? This gives you the bright. Because now if we divide 3 parts, then 2 parts will cancel out from suppose these 2. The third part will remain unaffected, which gives you what? Bright. So from equation 1, here it is 3 lambda by 2, it is d sin theta 1, or sin theta 1 is 3 lambda by 2. So this is first secondary maxima. So similarly if we take x is equal to 5 lambda by 2 and theta is equal to theta 2, then from equation 1 you can write sin theta 2, it is 5 lambda by 2d. So this will be secondary maxima. Kyunki if we consider 5 lambda by 2, 5 lambda by 2 means what? Here this 5 lambda by 2. In this case, the slit is divided into 5 equal parts. 1, 2, 3, 4, 5. Now, from the first two part, these two cancel out. From next two part, these two cancel out. From the last part, these remain unaffected, which gives you what? Right. So this way, in general, for nth, what will be that? You see, sin theta 1, 3 lambda by 2d, sin theta 2, 5 lambda by 2d. That means it is odd multiples. For nth, you can write sin theta n, it will be 2n plus 1 lambda by 2d. So this is for nth. Okay? This is for nth. Now again, similar we can find out tan theta. So in triangle COP, you take tan theta n, it is perpendicular by base, that is yn by d. Now if theta n is very small, then you can write tan theta n equal to sin theta n. So tan theta n means what? Yn by d, and sin theta n means what? 2n plus 1 lambda by 2d. So from here you can find out the position, that is yn is equal to what? 2n plus 1 lambda d by 2d. So we got the position of nth secondary maxima and nth secondary minima from the center of the screen. Okay? Okay. Next is what? Width of secondary maxima and minima. Secondary minima. We will find the width of secondary maxima and secondary minima. So first of all, you see position of nth secondary minima, what you get? It is n lambda d by d. And for secondary maxima, what you got? Yn equal to 2n plus 1 lambda d by 2d. Now here you see, if n equal to 1, y1 is equal to lambda d by d. If n equal to 2, y2 is equal to what? 2 lambda d by d. If n equal to 3, y3 will be what? 3 lambda d by d. Similarly, here you see, if you take n equal to 1, y1 will be what? 3 lambda d by 2d. If n equal to 2, y2 will be 5 lambda d by 2d. If n equal to 3, y3 will be 7 lambda d by 2d. Now here you see the separation between any two dark. You see here. Any to dark, it will be what? If we take the separation difference, it is lambda d by d. Any two. Second and first, third and second, lambda d by d. Similarly, here also, separation between any two consecutive bright. It is what? You take the difference, lambda d by d. Here also it is what? Lambda d by d. So here you can say that all the secondary maxima and all the secondary minima are of equal width. And that is called what? Fringe width, or simply width of secondary maxima or minima. That represented by beta, so it will be lambda d by d. So that you remember this. Okay, this is the width of secondary minima or secondary maxima. So this is the width of secondary minima or secondary maxima. Okay, so all the secondary maxima and minima are of equal width, and that is lambda d by d. Now let me find out the width of central maxima. Width of central maxima. Central maxima. So here you see, this is suppose a central maxima. This central maxima. Okay, this is central maxima. Central maxima. So here this is minimum intensity. So it is first minima. It is first minima. Okay, first, secondary, minima. This is also first, secondary, minima. So this is the width of central maxima. So this suppose beta naught. So this is the position of first minimum on right side. This is also position of what? First minimum on left side. So you can say that width of central maxima, width of central maxima is equal to what? 2y into y1. That means what? From here to here, that is 2 into position of first, secondary, minima. So the width of central maxima is equal to what? Twice the position of first, secondary, minima. So that you can write beta naught is equal to twice of what is y1? So yn we know. For secondary minima, yn is what? N lambda d by d. So it is y1. So put n value 1. So it is lambda d by d. So beta naught is the width of central maxima, that is 2 lambda d by d. Or simply you can write twice beta. So beta is the width of secondary minima and maxima. So width of central maxima is what? Twice of beta. Same way you can remember that angular width of central maximum is equal to twice the angular width of first minimum. Twice the angular width of first, secondary minimum. Because why you see, this is central maximum, this is first minimum, this is also first minimum. So this is suppose theta 1, this is theta 1, this is theta naught. So width of central maximum is equal to twice the width of what? First minimum. So this you can write theta naught is equal to twice of theta 1. So this is very important. So in questions, you may ask to find the width of central maximum. So to find the width of central maximum, first you have to find out the angular width of first, secondary minimum. To find the first, secondary minimum, then by multiplying 2, you will get the angular width of what? Central maximum. Okay? Next is what? Fresnel distance, that is variability of ray optics. Variability of ray optics. So Fresnel distance means what? Here you see, this is suppose the slit. Okay, this is suppose screen. This is slit and this is screen. Now here, if we assume light travels in straight line, means ray optics. If you can say ray optics, light travels in straight line, then this light will travel like this way. That means you will get light only here. Only these sections you will get light. If we assume light travels in straight line. So this is the case of what? Ray optics. This is the case of what? Ray optics. If we assume light travels in straight line, means ray optics, then light travels along this way. So you will get light only in these regions. Here and here you will get no light. Okay, no light in this region. But if you assume light travels in wave, light is a wave, in that case there will be diffraction, because diffraction is the phenomenon of wave optics, means from there is a bending. There is a bending of light. So you will get light here. You will get light in this region also. Here also you will get light. So you can have light. You can have light in this region. So you will get light in this region, here, that due to what? Wave optics. So here you will get light due to wave optics. Here also you will get due to wave optics. Okay? Wave optics. But these portions, the light is because of what? Ray optics, because light travels in straight line. Here is bending is because of diffraction, and diffraction is phenomenon of what? Wave optics. So that means up to this distance you can say ray optics valid. From here to here, ray optics valid. Then from this distance you see here, this for wave optics. So this is the distance, slit with D. So up to this distance, this D, up to this distance here to here, it is the ray optics. That distance is called what? Fresnel distance, we denote it by ZF. So ZF is equal to D. What is D? D is the distance between slit and screen. It is D. Now, if D is equal to ZF, up to this distance, your ray optic values. If distance is greater than ZF, this distance, wave optics valid. So for this region, when ZF, so let us find out ZF first. So this distance here, wave optics valid, and here to here, ray optics valid. So the distance up to which ray optics valid, that distance is called what? ZF. Okay, distance greater than ZF, your wave optics valid. Now how can we find ZF? ZF you can calculate that when D equal to ZF, that means distance between slit and screen is what? Is equal to ZF, then spreading of the central maximum is minimum. Because here you see, here I am considering this one, that there is no spreading. Then after that there is spreading. Spreading means what? This is the original line. So it spreads to this region. Spreads. This spreading, what? Spreading of light increases. So here the spreading is minimum. Okay? Spreading is minimum. So you can say that when B equal to ZF, then the spreading, this Y1 is equal to what? Y1 is equal to D. Now Y1 means what? If we draw the slits, if we draw the intensity graph, here you see this is the central maximum. So this is the spreading. Here center, and this is the spreading. This is Y1. Okay, this is Y1. Spreading from center. Okay. So when the distance D is equal to ZF, means Fresnel distance, the spreading of central maximum is minimum, and that is equal to what? D. D means what? Slit width. Now, Y1 is equal to what? You use the formula lambda D by D. So here, Y1 is what? D. Lambda D is what? ZF by D. So from here, ZF is equal to what? D square by lambda. Now this distance is called what? Fresnel distance. Okay. Now what is the importance of Fresnel distance here? You can say if distance D is less than ZF, here ray optics valid. If distance more than ZF, wave optics valid. So this is the validity of what? Ray optics. Okay. Intensity distribution graph of single slit diffraction. Single slit diffraction. Now in diffraction, the intensity of bright fringes is not constant, does not remain constant. In interference, what we have seen, the intensity of all the bright fringes remain constant. But in diffraction, the intensity does not remain constant. Why? You see, as we have seen, that in diffraction what happens when light enters, you know, this region is of maximum intensity. Okay, intensity. And this is nothing but central maxima. Okay, central maxima will form here. Now, if we go away from that, if you consider diffracted beams here, as we go these are diffracted beams. So as we go away from the center, intensity gradually what? Decreases. Intensity gradually what? Decreases. So you can say that in diffraction, the intensity of light gradually decreases with the order of maxima. Okay, order of maxima. So if we draw a graph, it will be something like this. It will be something like this. Like that. Okay. So this will be central maximum. This is first secondary maximum, second secondary maximum. Here first secondary maximum, second secondary maximum. That means as we go away from the center, the intensity gradually what? Decreases. This is the case of diffraction. But in interference, you will find that all the bright fringes are of what? Equal intensity. So this is one of the basic difference between what? Interference and diffraction.